Hey, everybody, let's do some review for Math 35. Last session, we did partial fraction decomposition, the king of factoring, so to speak. Normally we've done factoring in the numerator, but now it's factoring the denominator. Just as a quick reminder, when we have stuff where it's already factored on bottom, anything that has an x to the first power, we can write it as a denominator. And we'll put pluses between them, which may later on turn to minuses. We don't know until we figure out what the numerators are. So that's the general form. If we multiply through by the denominator, we get 4x squared minus x minus 15 on the left. On the right, we have a gets every other denominator, so it gets x plus 1 and it gets x minus 1. B gets every other denominator, it gets x and x minus 1. And C gets every other denominator, so x and x plus 1. Now, one way is to multiply them out and match up coefficients. I think the easiest method is to see what zeroes out the denominators, especially when there's no repeats. See what zeroes out a denominator and plug it into this formula right here. So I have x equals 0, makes that a 0 on the denominator. -1 would make this one a 0 on the denominator, and +1 would make that one a 0 on the denominator. So we will test those. Let's just see what happens if we plug in x equals 0. The left side, everything goes away except -15. On the right side, I have a times 1 times -1. And then plus b times 0 and plus c times 0. I could put the other stuff in there, but as soon as I see it's times 0, I know that goes away. That's the whole point of doing this method. And we see that -15 equals -a. So a equals 15. And we're trying to find a, b, and c. We stick in -1. The left side is 4 times -1 squared minus -1 minus 15. And then anything that has, I can see where the x equals -1, anything that has the x plus 1 component is going to zero out. So a is going to have a 0 and c is going to have a 0. I'll put that in for now, just to illustrate it. Make sure that it's clear that stuff's not just disappearing. That's 0 and that's 0. So we gotta do some cleaning up. This is -1 squared is 1 times 4. And I got minus a -1 is a plus 1. So I got 5 minus 15 is -10. On the right side, I have -1 times -2 times b is 2b. So I end up with b equals -2 or -5. And we'll do the same thing for x equals +1. I've got 4 times 1 squared minus 1 minus 15 equals. And now anything with the x minus 1 component zeroes out, which should be everything but the one that's underneath. So c should remain, and that's the case. If I stick in 1 here, 1 minus 1 is 0. 1 here, 1 minus 1 is 0. So a has a 0 coefficient and b has a 0 coefficient. C has 1 times 1 plus 1. Let's go to 0. On the left side, I've got 4 minus 1 minus 15 is negative, 4 minus 16 is negative 12. On the right side, I've got 1 times 2 times C is 2C. So I get C equals negative 6. We're not done. We don't want to just find the coefficients. We need to rewrite it in factored form. I'll just, let's see, A is 15. And then I've got plus B, but B is negative. So I can make it actually negative and put the negative out front and do it like that. And C is also negative. So I can put the negative out front there and do it like that. If you wanted to check your work, multiply everything by the big denominator. X times X plus 1 times X minus 1. And once you've multiplied it all out and you've added together like terms, you should get the left-hand side's numerator. You guys ready for one? Unless someone says otherwise, I'm turning the page.
Yes, I'm ready.
Okay. So let's give you guys one. Let's see what we want to do. Let's do 5x minus 3 over x squared minus 2x minus 3. I'll let you work on it for 5 minutes or so, and then we will do it together. Beautiful. Oh, the beautiful people. All right, so let's see how you guys did. What was the first thing you guys chose to do?
Is it when you do the equal and then you do like the A, B, C stuff?
Yeah, but so, okay, so what do I do with that?
So you're gonna put A over X, because it's an X squared on the bottom.
Okay. I like the idea. That's not quite what we do though. We need to use factors of this first. So we actually need to factor it first.
Oh, okay, sorry.
I gave you, and that's okay. I'm glad that's why we do this class. To get rid of some of those questions or misconceptions early. The idea is to factor this first because we want factors underneath it like we did in the last one. They need to be multiplied together, and here they're added and subtracted together, so that doesn't work. So if we factor this, we should get x minus 3 and x plus 1. With that, we can do the a and the b. And if I multiply through by the common denominator, I get 5x minus 3 equals a times x plus 1 plus b times x minus 3. The things that'll make my denominators equal 0, x minus 3 equals 0 shows that x equals 3 is one of them. And x plus 1 equals 0 shows that x equals -1 is one of those. So we'll try both of those and see what we get. So if x equals 3, the b goes away. Let me do the left-hand side first though. I got 5 times 3 minus 3 equals a times 3 plus 1 plus b times 3 minus 3. We can see that goes to 0 like we meant. And I get 15 minus 3 is 12 on the left side. On the right side, I get 3 plus 1 is 4, I get 4a. Which shows me that a equals 3. And we'll take a look at b. We want to do the other one if x equals -1. This is going to zero out the a, but let's take care of the left-hand side first. As intended, that went to 0. On the left side, I have -1 times 5 is -5, minus 3 is -8. Ah! Ah! Holy shit. Damn, that was a sneeze.
Bless you, bless you.
Thank you. On the right side, -1 minus 3 is -4. So I've got -4b. I divide by -4 and I get +2 for b. So we can come up to the top and rewrite 5x minus 3 over x squared minus 2x minus 3 as a goes on top of the x minus 3 and 2 goes on top of the x plus 1. Any questions?
We're gonna do another one of these or no?
Yeah, we're doing these for the another half hour.
Okay, good.
All right, so another one we can do is let's take a look at this one. This has a little bit of a twist, so I'm going to walk you through it. Recall when there's plus signs or minus signs in between them, we got to factor first. If I factor this, I get x plus 1 times x plus 1 on bottom, which is x plus 1 squared. Now, if I looked at this, I could easily want to go, okay, that's x plus 1. And that's the other one's x plus 1 and do that. But then we'd have the same denominator and we could just add them together and it wouldn't work. So the way we have to deal with it when a factor repeats is on the second one, however many times it repeats, we keep doing that denominator and adding a new exponent. So for like example, if it was x plus 1 cubed, we'd have a c over x plus 1 cubed also, in addition to the 2 I already have. But we don't. And this is where we get a little bit stuck, but let's see what we can do. We can multiply through and clear the fractions. So I'm going to multiply everything by x plus 1 squared. The left side, the denominator should go away. If I multiply the a times x plus 1 squared, one of them goes away, but the other one doesn't. And on the b, both of them go away. Something's off here. I don't know if this is going to produce anything. This might give us just zeros. This may not work. Did I factor this right?
Yeah, I'm pretty sure you did factor it. Right.
Yeah. Because if I distribute, I have ax plus a plus b. Which means if I align coefficients, there is no x squared. So for x's on the left side, I have 0 on the left side. On the right side, I have a times x. So a has to equal 0. And then for constants, I have 0 constants. And on the right side, I have a plus b. But if a equals 0, this says b equals 0. So I'm getting 0 for both of these. Which means maybe this doesn't factor. That looks funny.
I have a question.
Yeah.
You do the normal thing where you put in an x value, for example, x equals -1, and the first x squared equals a times x minus x plus 1 plus b.
Uh-huh.
If you put in x equals -1, don't you get b equals 1?
Yeah. No, yeah, we do. So why is this working different? You got a good point. And then, wow, why is this giving me the wrong answer then? I still have a plus b equals 0. Those are the constants. And if b equals 1, a equals -1. So this is saying x squared over x squared plus 2x plus 1 can be broken into -1 over x plus 1 plus 1 over x plus 1 squared. Which is weird, because we already have the x plus 1 squared. I know what I did wrong. I know exactly what I did wrong. Let's see, let's work this out though. Let's make sure. Let's clear the fractions and see what happens. Let's multiply by x plus 1 squared. If I do, I have x squared equals -1 times x plus 1 plus 1. And I get x squared equals -x minus 1 plus 1. X squared equals -x. So those don't work. They don't work. So the problem is, there's a step to do before that. What we have to do first, the problem is these have the same exponent, which means I have not simplified same exponent. I have not simplified these enough. I need to simplify first. So I'm going to do that on another page. This unfortunately has us doing some long division. This goes in -1 time. And I have -x squared minus 2x minus 1. Actually, it goes in with +1 time, I should say, and then we subtract. And we subtract, and I get -2x minus 1. So x squared over x squared plus 2x plus 1 equals 1 plus -2x minus 1 over x squared plus 2x plus 1. Now, the exponent on top is lower than on bottom. And now we can factor it. Still has that x plus 1 squared. What we had up here still applies. We're ignoring the 1 for now. I'm just leaving it there to make sure we don't lose it. And so what we're working with, again, is we have the negative 2x minus 1 equals a times x plus 1 plus b. So if we do the x equals -1 thing, I have -2 times -1 minus 1 equals a times 0 plus b. So -2 times -1 is +2, 2 minus 1 is 1. So b equals 1. And I can line up coefficients here. And that tells me -2 has to equal b.
You mean A?
Yeah, I mean, I just realized what I wrote there. So we go all the way back up to this sumbitch up here. So x squared over x squared plus 2x plus 1 equals, don't forget this 1 here, 1. And then I've got -2 for the a, so I'll put negative there. And then I've got +1 for b. And I don't know that I remember to point that out in class on Wednesday. So if the numerators. Yeah, that'll work. If there, so if there is an exponent in the numerator. Greater than or equal to the largest exponent in the denominator. Do long division first. All right, you guys ready for another? There was one more idea we had in this chapter, and that's when the denominator had a square in it that we couldn't factor. So let's do one of those. We're gonna do each fact, these are all multiplied together. That's times that times that. So we can do that for each of them. Make them each a denominator. X squared plus 1 does not factor without being a complex number. So this one will have an A, this one will have a B. And then when you have a square here, we got to put on top a polynomial of 1 degree lower. 1 degree lower. So something with an X. I need something with an X. It could have a coefficient and it could have a constant with it as well. You'll notice all of these do 1 degree lower. Now we clear fractions. And we have two things that we can at least check. We can check this one, the denominator would be x equals 0. Here's x equals -1. We can at least do those and see what we get for A, B, C, and D. See what falls out. So let's try that. If x equals 0.
One sec. So at the end there, you have plus c times x
I fucked
times
that
x
up.
plus 1.
My bad.
Okay. Okay.
Holy shit. That is not C, that is CX plus D. There we go. Thank you. That was about to go downhill rather quickly with the wrong, some wrong word going on there. All right, if x equals 0, the left side doesn't change. Left side's 3 no matter what. The right side, I have A times 0 plus 1 is 1. And 0 plus 1 is 1. The B has a 0 there, and the C has a 0. CX plus D has a 0. From there. So I'm left, those go to 0, and I'm left with 3 equals A. That's nice. If we do the x negative equals -1, we got 3 equals. Anything with an x plus 1 is going to go to 0. So the A has a 0 on it. The B does not. But the CX plus D does. From there. So I have 3 equals negative, this is -1 times 2, -2b. So b equals -3/2. All right, so what can we do for C and D? Let's go ahead and multiply that shit out up here at the top. It's not going to be pretty. I have A times x cubed plus x squared plus x plus 1. And on the B, I have x cubed plus x. And this is a clusterfuck. I'm going to do it in parts. I've got the x. I'm going to distribute the x plus 1 and the cx plus d. I got cx squared plus cx plus dx plus d. Which is cx cubed plus c plus dx squared plus dx on that one. And I'll distribute the other things over here. All right, it's ugly. But we can start looking at the different things that make it up. X cubed. The x cubed terms, we have an ax cubed plus a bx cubed plus a cx cubed on the right-hand side. On the left-hand side, we have a 0. And I know what A and B are already. So ignoring the x cubes, I have 3 minus 3 halves plus c equals 0. Which means c also has to be negative 3 halves. Now, if I look at my x squareds, all I need left is d, and d, there's a dx squared and there's a dx. So we either got to do x squared or x to find that d. I think there's less x squareds in here. I only see the ax squared and the dx squared. I see ax squared plus dx squared equals 0x squared. And I'm pulling that from here and here. Oh, no, there's a cx squared too. What am I fucking doing? Ax squared plus cx squared plus dx squared equals 0x squared. Before Christopher corrects me.
I had also missed it until you mentioned it.
Oh. All right, let's plug in what we got. We know ignoring the x squareds, a is 3, c is negative 3 halves, and we've got d. This looks exactly what we did for c. So d has to equal negative 3 halves also. So putting this all together, I'm going to show what cx plus d over x squared plus 1 looks like up here first. This is negative 3 halves x plus or minus 3 halves over x squared plus 1. We can put the 2 on the bottom. This can be negative 3x minus 3 over 2 times x squared plus 1. We could even factor the top a little bit more and make it negative 3 times x plus 1 over 2 x squared plus 1 if we wanted to, but it's not essential. We got to go back to the beginning now. We had 3 over x times x plus 1 times x squared plus 1. That has to equal a over x, and a is 3. And it has to equal b over x plus 1. B is negative 3/2. I can put the 2 on bottom. And I just showed this. I'm actually gonna do this version right here, at least with the negative. I can call this 3x plus 3 on top over 2 times x squared plus 1. I just factored out the negative and not the 3. And presumably, if we did everything correctly, if we multiply through by x times x plus 1 times x squared plus 1, we take this and multiply by x times x plus 1 times x squared plus 1, we're gonna get 3 when we're done. Should equal the numerator on the left. And that's it for the 3:35 hour. We will be back with you in 10 minutes to do the next section. I mean, you guys have any questions? All right, let me hear some.
One sec. I had sent you an email asking about the fact that your fall class for Calculus 1 isn't listed yet.
I did not see an email. Let me go look at it.